Hello friends, once again welcome to your favorite pharma channel Ram Pharma Academy. Myself Mr. Ram Ford, Assistant Professor at Maharashtra College of Pharmacy Nilanga. In today's lecture we are going to cover structure and IUPAC name of anticonvulsant drugs. It is important for Medicinal Chemistry 1 B Pharmacy second year semester 4 examination. In the examination you will be asked to draw the structure and give its IUPAC name. There, this video will be useful for you. One more important question asked from this topic is classify the anticonvulsant drugs on the basis of chemical structure and draw one structure from each class, where we have to classify all these drugs on the basis of chemical structure and then you have to draw the one structure from each class. This question we are going to cover in this lecture. Friends, I have to take lot of efforts to make this type of videos, so please like and share the video with all your friends and don't forget to subscribe to our channel to get the regular updates. Friends, it takes only few seconds for the sharing, so please share the video. Let's start today's topic. Anticonvulsant drugs, which are more accurately called as antiepileptic drugs, or more oftenly they are called as anti-seizure drugs, because these drugs are useful in the treatment of epilepsies. About epilepsies we will learn in another video. Here we are going to focus only on the drugs with their structure and IUPAC name. So this is the chemical classification of anticonvulsant drugs, where these drugs are classified into the 11 classes like barbiturate derivatives and the name of molecules methabarbital, phenobarbital, and this is the classification I have made, and all these drugs are included in your PCI syllabus copy. Barbiturate derivatives like methabarbital, phenobarbital. Then second class of molecules are deoxybarbiturate. One molecule is there, primidone. Then third class is hedantoin derivative. Important molecule is the phenytoin, then mephenytoin, ethotoin. Then fourth class is oxazolidinedione. And the examples are trimethadione, paramethadione. Then fifth class is succinimide derivatives, where molecules are phensuximide, methosuximide, ethosuximide. Sixth class is the aliphatic carboxylic acid derivative. Example is valproic acid. Then seventh class is benzodiazepine derivative. Example is clonazepam. Then eighth is immunostilbene derivative. Example is carbamazepine. The ninth class is the cyclic GABA analog, and the example is gabapentin. 10th class is the monoacyl ureas, and the example is phenacimide. And 11th or the last chemical class is the carbamate or the carbamic acid derivative, and the example is philbamate. One by one we are going to cover all the chemical classes with their structures and IUPAC name, and we'll see how they are belong to those classes: barbiturate, deoxybarbiturate, hedantoin, all the classes, so that you can easily remember the structures with their IUPAC names. In the previous lecture, in the sedatives and hypnotics, we have already covered the barbiturates and benzodiazepine. You can go there and watch that video also. Link is given in the description. Once again, we will see what are the barbituric acid derivatives. So this is the structure of barbituric acid. First we will give the numbering to this molecule. Then we will see how IUPAC name is given to the barbituric acid. Actually, if you look at the structure of barbituric acid, it is made from the heterocyclic ring pyrimidine. Structure is drawn towards the right side. This heterocyclic ring is known as pyrimidine ring. Now we'll see how IUPAC name of barbituric acid is given, so that you can easily draw other structures belonging to barbiturates and give their IUPAC names. Pyrimidine, because it is reduced form of pyrimidine. 2,4,6 trione, because on the second, fourth and sixth position ketone groups are there, therefore 2, 4, 6 trione. And in bracket we have to put 1H, 3H, 5H, because in pyrimidine you can see there are 3 double bonds between first and second, third and fourth, and fifth and sixth carbon, and we have to show the reduction of those bonds by placing 1H, 3H, 5H into the bracket. So this is the IUPAC name of barbituric acid. Now we'll see the first molecule belonging to the barbiturate is the methabarbital. If you have gone through the sedatives and hypnotics, we have seen the barbital structure. This is the structure of barbital, and in which you just have to put this methyl group on the nitrogen. That's why the name of molecule is methabarbital, because one methyl group is extra on the barbital. Now we'll give the numbering, and then we'll see how IUPAC name of methabarbital is given, and also each below the name of each molecule I have shown its chemical class also in the blue color. You can go through that. Now we'll see how IUPAC name is given. 5,5-diethyl, because on the fifth position over here you can see two ethyl groups are there, therefore 5,5-diethyl. One methyl is present on the first position. Then pyrimidine 2,4,6 into bracket 1H 3H 5H trione. This is the barbituric acid structure. So all the barbituric acid derivatives ends up with this name, pyrimidine 2,4,6 in bracket 1H 3H 5H trione. Next molecule is the phenobarbitone or the phenobarbital. Both molecules are same, they are synonymously called as phenobarbitone or phenobarbital. Now we'll give what is the difference between first molecule and second molecule. We have to remove the methyl group from the nitrogen, and then you have to replace one ethyl group with the phenyl ring on the fifth carbon. Now we'll see how IUPAC name is given. 5-ethyl, this ethyl group is present on the fifth position. Then 5-phenyl for this phenyl ring on the fifth position, and the rest of the name is similar to barbituric acid, because other part is only the barbituric acid, on which on the fifth position you have to put one ethyl and one phenyl group, and it forms the phenobarbitone or phenobarbital. So this is the IUPAC name of phenobarbitone, important molecule used in the treatment of epilepsy. Then next molecule is the primidone. It belongs to the second class, that is deoxybarbiturate. Why it is called as deoxybarbiturate? Because from the barbituric acid one oxygen is removed on the second position. Over here you can see in barbituric acid you have the ketone group at the second position, but in case of deoxybarbiturate this ketone group is removed. Therefore it is known as deoxybarbiturate. Now we'll see how IUPAC name is given. 5-ethyl for this 5-ethyl, 5-phenyl, this 5-phenyl, pyrimidine 4,6, pyrimidine 4,6 into bracket 1H, 3H, 5H dione. Why dione? Only two ketone groups are present on the 4 and 6. So what is the difference between the two structures, phenobarbitone or phenobarbital and primidone? The difference is only at the second position where ketone group is removed in case of primidone. Actually primidone is a prodrug which converts into the phenobarbital inside our body after the metabolism. Means primidone is actually a prodrug and it converts into its active metabolite phenobarbital inside the body after metabolism. Now we'll see next class of molecule, that is head-and-toin derivatives. First we'll see what is head-and-toin. You know the structure of imidazole. This is the structure of imidazole, which is 5-membered ring with 2 nitrogens at 1 and 3rd position, is known as imidazole, which has 2 double bonds. You can see 2 double bonds are there. If you remove or reduce those 2 double bonds, then it forms the imidazolidine. You must know the difference between imidazole and imidazolidine. Then if you put 2 ketone groups on the imidazolidine, and then we'll give numbering and we'll see how IUPAC name is given, because it is important to know what is head-and-toin. Here you can see this is imidazolidine, and this molecule also has imidazolidine group. Then on the 2nd and 4th position over here 2 ketone groups are present, therefore imidazolidine 2,4 dione. Why dione? Because 2 ketone groups are there, and this group is commonly known as head-and-toin ring. Means imidazole ring with 2 ketone groups is actually known as head-and-toin. Now we'll see first molecule belong to the head-and-toin class is the phenytoin. First we'll give the numbering, then we will see how IUPAC name is given. It's very simple. You can see This heterocyclic ring we have already covered, head and tail, which is also known as imidazolidine 2,4 dione, on which on the fifth position two phenyl groups are present. Therefore, 5,5-diphenyl imidazolidine 2,4 dione. Once again, we will see the IUPAC name of phenytoin. It is also one of the important molecule used in the treatment of epilepsy. 5,5-diphenyl, because two phenyl groups are present on the fifth position, 5,5-diphenyl. Then imidazolidine, this reduced form of imidazole is known as imidazolidine, and on the second and fourth position two ketone groups are present, therefore 2,4 dione. So this is the IUPAC name of phenytoin. Next molecule is the mephenytoin. What you have to do in the structure of phenytoin and mephenytoin, difference is on the fifth position and the third position. Here on third position you have to put one methyl group, and then on the fifth position you have to replace the one phenyl ring with the ethyl ring, and it forms mephenytoin. Now we'll see how IUPAC name is given. 5-ethyl on the fifth position, one ethyl group is present, then 3-methyl, one methyl group at the third position, then 5-phenyl for this phenyl ring at the fifth position, imidazolidine 2,4 dione. So this part is already well known to you, imidazolidine 2,4 dione. Next molecule is the ethotoin. It is also simple molecule. On the fifth position you have to replace the ethyl group, and on the third position replace methyl group with the ethyl group, and it forms the ethotoin. Now we'll see how IUPAC name is given. 3-ethyl, ethyl group at the third position, then 5-phenyl for this phenyl ring at the fifth position. The rest of the name is same, similar to previous molecules, imidazolidine 2,4 dione. So this is the IUPAC name of ethotoin. It also belongs to the head and tail class. Now we'll see next class of molecules, oxazolidine dione. First we'll see what is oxazole. So this is the oxazole ring, where it is 5-membered ring with oxygen and nitrogen present on the first and third position. If it is present on the adjacent position, that is 1 and 2, then it is known as isoxazole. And this is the oxazole, where oxygen and nitrogen are placed at 1 and 3rd position. And if you replace the two double bonds present in oxazole, it forms the oxazolidine. And when you put two ketone groups, it forms oxazolidine dione. First we'll give the numbering, then we'll see how IUPAC name is given. This heterocyclic ring is known as oxazolidine. Here also oxazolidine is present. On the second and fourth position, two ketone groups are present, similar to previous molecules, head and tail. Only you have to replace, what is the difference between head and tail and oxazolidine? You have to replace this NH in head and tail with the oxygen, and it forms oxazolidine 2,4 dione. We'll see the molecules belong to this class. First molecule is the trimethadione. The name of the molecule itself suggests that 3 methyl groups are present, trimethadione. Now we will give the numbering, and then we'll see how IUPAC name is given. Here you can see on the third position, fifth position, methyl groups are present. Therefore, 3, 5, 5. Total 3 methyl groups are present. Therefore, trimethyl 1, 3 oxazolidine. On the first position and third position, oxygen and nitrogen is present. As oxygen is present, you have to put oxa, and as nitrogen is present, you have to put aza in the name. Therefore, 1, 3 oxazolidine, as it is a reduced form, oxazolidine 2, 4 dione. On the second and fourth position, ketone groups are there. Therefore, it is 2, 4 dione. So this is the IUPAC name of trimethadione. 3, 5, 5 trimethyl 1, 3 oxazolidine 2, 4 dione. Next molecule belonging to this class is paramethadione. First we'll give the numbering, then we'll see how IUPAC name is given. What is the difference between previous and second this molecule, paramethadione? You have to replace one methyl group on the fifth position with ethyl group, and it forms paramethadione. Now we'll see how IUPAC name is given. 5-ethyl, or this ethyl group on the fifth position, then 3, 5 dimethyl on the third and fifth position. Methyl groups are present, therefore dimethyl, 3,5 dimethyl, and the rest of the name is similar to previous molecule. 1,3 oxazolidine, 2,4 dione. Now we'll see the next class of molecule that are pyrrolidine 2,5 diones, or they are more commonly called as succinimide derivatives. First we'll see what is pyrrole. 5-membered ring with one nitrogen is known as pyrrole with 2 double bonds. If you reduce those 2 double bonds, it forms the pyrrolidine. And if you put 2 ketone groups, it forms the next molecule, which is known as pyrrolidine 2,5 dione, which is more commonly known as succinimide. Why succinimide? You know the structure of succinic acid? So this part is actually from the succinic acid, CH2CH2, and on the both CH2, 2 carboxylic groups are present, which is example of dicarboxylic acid, and it forms the amide with the ammonia and forms the succinimide. As it is the imide of succinic acid, it is known as succinimide. Now we'll see the drugs belonging to this class, succinimide. 3 molecules are belong to the succinimide class. Phensuximide, from the name itself suggests phenyl ring is present in the molecule. Now we'll see how IUPAC name is given. 1 methyl group on the first position, then 3 phenyl, 1 phenyl group at the third position, pyrrolidine 2,5 dione. This is the reduced form of pyrrole, which is known as pyrrolidine, and on the second and fifth position 2 ketone groups are present, therefore 2,5 dione. Friends, while remembering structures, we have to identify the differences between the previous molecules and next molecules so that you can easily remember the structures. So this is the structure of phensuximide. Now we'll see the next molecule, that is methosuximide. What is the difference between phensuximide and methosuximide? Only you have to put 1 methyl group on the third position and it forms methosuximide. And the name of molecule itself suggests that there is 1 methyl group present. Now we'll see how IUPAC name is given. 1,3 dimethyl, on the first and third position methyl groups are there, 2 methyl groups, therefore 1,3 dimethyl. 3 phenyl, 1 phenyl group at the third position. Pyrrolidine 2,5 dione. Pyrrolidine 2,5 dione. So this is the IUPAC name of methosuximide. Next molecule is the ethosuximide. What you have to do? You have to replace the phenyl ring on the fifth position with the ethyl group, and you have to remove the methyl group on the nitrogen, and it forms ethosuximide. I will see how IUPAC name is given. So this is the IUPAC name of ethosuximide. 3 methyl, on third position methyl group is there, then 3 ethyl, 1 more ethyl group on the third position, then pyrrolidine 2,5 dione. This reduced form of pyrrole is known as pyrrolidine, and on the second and fifth position 2 ketone groups are present, therefore 2,5 dione. So this is the IUPAC name of ethosuximide. Now we'll see the next molecule, which is a aliphatic acid derivative or aliphatic carboxylic acid derivative. You know the aliphatic chain, long carbon chain without any unsaturation is known as aliphatic chain, and as it has carboxylic group, it is known as aliphatic carboxylic acid derivative. Here you can see this carboxylic acid is present, and longest carbon chain is the 5 carbon chain, therefore name of molecule contains pentanoic acid. And on the second position over here, this 3 carbon chain is present, that is 2 propyl. On the second position propyl group is present, therefore 2 propyl, this propyl, then pentanoic acid, carboxylic acid with 5 carbon is known as pentanoic acid. This is also one of the important drug used in the treatment of epilepsy, valproic acid. Next chemical class is the benzodiazepine derivative. We have already covered this benzodiazepine derivatives in the sedatives and hypnotics. Please go and watch that video also. We'll see how IUPAC name is given to this molecule, and the molecule belonging to this class is clonazepam. Now we'll see how IUPAC name is given. 5 on the fifth position over here, 2 chlorophenyl. If you give the numbering to the benzene ring, then chlorine gets the second number, 2-chlorophenyl, then 7 nitro. On the 7th position nitro group is present, therefore 7 nitro. 1,3 dihydro, because the double bond over here is reduced, therefore 1,3 dihydro, which is reduced by addition of 2 hydrogens, therefore dihydro. 1,4 benzodiazepine, benzo because of this benzene ring, and 1,4 two nitrogens are present and at the first and fourth position, therefore 1,4 benzodiazepine. Why di? Because of 2, and aza means nitrogens, 2 nitrogens. Azepine, pin is for this 7 membered ring. Then 2-one because of ketone group on the second position. So this is the IUPAC name of clonazepam. 5 into bracket 2-chlorophenyl, 7 nitro, 1,3 dihydro, 1,4 benzodiazepine, 2-one. So this is the IUPAC name of clonazepam. Next chemical class is the immunostilbene derivative, and the drug belonging to this class is carbamazepine. This immunostilbene is also known as dibenzodiazepine. Actually, it is fused form of the 2 benzene ring with the azepine heterocyclic ring. Here we'll see first what is immunostilbene. So this part, heterocyclic ring, is known as immunostilbene, which is also known as dibenzoazepine. Dibenzo means 2 benzene rings with 1 azepine ring, therefore dibenzoazepine. Now we'll see how IUPAC name is given. 5H, because hydrogen is replaced with the one substituent 5H on the nitrogen. Dibenzo for these 2 benzene rings. Into square bracket you have to put the letters B, F. Why? Because at the intersection of B and F sides it is attached with the azepine ring, therefore B, F. Azepine, 7 membered ring with 1 nitrogen and 3 double bond is known as azepine. 5 carboxamide. On the 5th position over here you can see this CONH2 group is present, which is known as carboxamide, therefore 5 carboxamide. So this is the easy IUPAC name of carbamazepine. It is also one of the important drug in the treatment of epilepsy. Next molecule which belonging to the class of cyclic GABA analog. Why it is called as cyclic GABA analog, that we will see, and the name of the molecule belonging to this class is gabapentin. Why gabapentin, that also I will show you. First we will see this molecule. This molecule drawn over here is the, first we will give the alpha, beta and gamma symbols, then we will see how IUPAC name is given to this molecule. How name is given to this molecule. It is GABA. You know, this is the carbonyl carboxylic acid group, and this is the carbonyl group, and adjacent carbon is known as alpha carbon, next carbon is known as beta carbon, and then next carbon is known as gamma carbon. And on the gamma carbon over here you can see one amino functionality is present, therefore the name of this molecule is gamma amino butyric acid. Why butyric acid? Because it is a 4 carbon containing carboxylic acid, that's why it is known as butyric acid. And on the gamma position amino group is present, therefore gamma amino butyric acid, and the short form is GABA. It is one of the important neurotransmitter involved in the central nervous system that we will cover in the next or upcoming videos. Now we will see how it is a cyclic GABA derivative. On the same molecule GABA you have to put one cyclic ring over here, you can see. That is the only difference between the gamma amino butyric acid and gabapentin. Why gabapentin? GABA means gamma amino butyric acid, and you have to put 5 carbons over here. You can see, count the number of carbons, 5 carbons, therefore pentin. Now we will give the numbering and we will see how IUPAC name is given. So this is the IUPAC name of gabapentin. 1 on the first position over here, amino methyl. This group NH2 and CH2 is known as amino methyl cyclohexyl. This 6 membered ring without any double bond is known as cyclohexyl ring. Acetic acid, this part, CH3COOH is known as acetic acid, and on the CH3 we have to replace one hydrogen with this amino methyl cyclohexyl group, and it forms the gabapentene. So this is gabapentene. Now we'll see the next molecule, which is a monoacyl urea derivative, and the name of molecule is phenacimide. First give the numbering to the numbering is very easy. Now we'll see how IUPAC name is given. IUPAC name is also very easy. Why it is called as monoacyl urea? You know the structure of urea? NH2CO NH2 is known as urea, and this part CH3CO is acyl group or the acetyl group. That's why it belongs to the chemical class monoacyl ureas, and the name of molecule is phenacimide. Why phenacimide? Phenyl acetyl amide, therefore it is known as phenacimide. Now we'll see how IUPAC name is given. N-carbamyl. On this nitrogen over here you can see this CONH2 group is present as a substituent. Then you have to write carbamyl group. This we have covered in the cholinergic system. There also you can see this type of group. Please watch that video also. Now we'll see the next part, 2-phenyl acetamide. On the second position phenyl group is present, and the central part, this part is actually acetic acid amide. CH3CO NH2 is known as acetamide. So this is the IUPAC name of phenacimide. Now the last chemical class for in the anticonvulsant drug is the carbamate derivative or the carbamic acid derivative, and the molecule is felbamate. First we will give the numbering, then we will see how IUPAC name is given. So this is carbamic acid derivative. Why carbamic acid? This part and this part is belonging to the carbamic acid. That's why it is carbamic acid derivative. Now we'll see how IUPAC name is given. On the second position over here, phenyl group is present, therefore 2-phenyl. Then 1,3 propanediol. 1,3 this propane diol. Why diol? Because two groups are present. Diol. Dicarbamate. Two groups are present, therefore dicarbamate. Actually it is ester of carbamic acid, therefore name end up with the ATE. So this is the IUPAC name of felbamate. Friends, this is the end of the tutorial. So please like and share the video with all your friends, and don't forget to subscribe to our channel. Thanks for watching. Goodbye. Take care.